Hi guys, today I'm going to talk about Towers of Hanoi puzzle. So before going understanding the puzzle, we'll just see what is the background or the history behind the puzzle. Um, there is a story that about Towers of Hanoi puzzle, that there's an ancient temple in Vietnam um, where there is a large room with three towers surrounded by 64 golden discs. These discs are continuously moved by priests in the temple, and they just move one disc per day, one at a time. Okay, so according to the prophecy, when the last move of the puzzle is completed, the world will end. Towers of Hanoi is one of the classic problems to look at if you want to learn recursion. It is good to understand how recursive solutions are arrived and how parameters for this recursion are implemented. So how towers of Hanoi works? Okay, so you can understand that there are three towers with n discs placed one over the other. So the discs are stacked up. The objective of the puzzle is to move all the discs to another tower following these rules. Okay, so you just have to follow certain two very simple rules. One is only one disk can be moved at a time. No disks can be placed on top of the smaller disks. Okay, so the larger disks cannot be placed on the smaller disk. Okay, so you cannot place larger disk on the smaller disk. Okay, so by following these two rules, you have to move the stack of disks from one tower to another tower. Okay, so this is Towers of Hanoi problem. Okay, so you can just see the diagram over here. So there are three towers. Okay, so the first is source, which is named as A. The second is auxiliary, which is named as B. And the third is destination, which is named as C. So herein there are three discs. Okay, so the red disc and yellow and green disc. So the smaller disc is placed on the larger disc. Okay, so they're stacked up according to their sizes in decreasing order. Okay, so the discs are stacked according to their decreasing order. Okay, so in one tower, and the problem is that you have to move all these stacked up discs from one pole to another pole. Okay, so for example, you have to move them, all of them, to the destination pole or tower. Okay, so if you just see how many number of moves you need. Okay, so to move n discs. Okay, so the formula here is, this is mathematically derived formula, that for n discs, so to move n discs from one tower to another, you need 2 power n minus 1 moves. Okay, so you need 2 power n minus 1 moves. So if the number of discs are 1, the total number of moves is 1. You just move it from the source to the destination. And if there are two discs, then you need total of 3 moves. Then if there are 3 discs, then you need 7 moves. Then 4 discs, you need 15 moves to be made. And then for 5, you need 31 moves. So you can just observe that with one disk added, you can see the total number of moves are doubling here. So the number of steps almost double every time you insert another disk in the stack. Okay, so uh, the time complexity of Towers of Hanoi is exponential time complexity. Okay, so so we'll see how this puzzle works. Okay, so this is the initial position. Okay, so you can see that all the disks are stacked in the source um, tower. Okay, so the first move, so we just saw the first move, wherein we are moving the green disk to the destination. Okay, so this is the first move, and it is not violating the rule, because the first rule is that you have to move only one disk at a time, and then the second rule is that you should not place the larger disk on the smaller disk. Okay, so we didn't violate the rules, and the move is now valid. So this is the first move. Since I have taken 3 disks, okay, so the maximum number of moves that you need is 7. Okay, so this is the first move, and then so you can just see. So this is the second move. Okay, so you can see that yellow disk has moved to auxiliary tower. Okay, so again, this is not violating the two simple rules that we have talked about. So this is the second move. Now coming to the third move. Okay, so this is a third move where we are moving the disk from destination to the auxiliary storage, and this is again not violating the rules. Okay, so we are placing the smaller disk on the larger disk. Okay, so that's not a violation. Okay, so that's a valid move. So now we are moving the this is our fourth move. Okay, so we are moving the larger disk to the destination. Okay, so this is done. Okay, right. And then the fifth move. Okay, so um, so we are moving the smaller disk to the source again. Okay, so then the sixth move. Okay, so then the last move, which is the seventh move, and you can see that the disks are now moved from the source to the destination, and again they are stacked up. Okay, so this is how the puzzle should work. Okay, so what's the recursive algorithm for towers of Hanoi? The recursive algorithm for towers of Hanoi is that so the first step should be you need to make n minus one. I mean you need to move n minus one disks from source to auxiliary, and again you need to move n minus one disks from auxiliary to destination. Okay, so you just need to move the nth disk from source to the destination. So your step 2 will become your base case, and move 1 and move 3 will become your general cases. Okay, so Towers of Hanoi problem in C, program in C. Okay, so write recursive C program for Towers of Hanoi, where n disks are to be transferred from the tower S to tower D, with tower A as the auxiliary tower. Okay, so you need to move all the disks from the source S to the destination D, wherein A will be your auxiliary tower. So this is the problem which is there in most of the engineering colleges lab cycle. So this is the C program. Okay, so very simple C program. You can see that recursive code is always short and clear and simple. Okay, so this is your main function. Okay, so after hash include stdio.h, you do have your function prototype. The name of the function is tower, and it is not returning anything, it's void. And this has got 4 parameters. The first is the number of disks, and the rest of the 3 are your source, destination, and auxiliary. Okay, so that's your function prototype, and then you have your main function. Inside your main function, you're reading in the number of disks. Okay, so you're asking user to enter the number of disks, and upon entering the number of disks, then you're calling the towers function with the 4 arguments. Since the rest of the 3 arguments are characters, you're putting them in single quotes, and the number of disks is an integer, so you're not putting that in single quotes. And once the function call is made, now the function, the control transfers to the function. Okay, so inside the function, okay, so you're taking static int count is equal to 0, because if your variable, you need to keep a count on the number of moves. Okay, so you need to know whether the total number of moves have been made. Okay, so to know that, you need a variable which will sustain, or whose scope is whose lifetime is beyond the function calls. Okay, so exists even in the function calls. And if you're declaring it as an auto variable, then automatically the lifetime is only within the function. So you need a static variable so that the lifetime will still exist even in the function calls. So we are just taking static int count is equal to 0, and we just need the base case and the general case. As I have already told you that you need only 3 steps over here. Okay, so wherein your first step and the third step is your general case or your logic, and moving nth disk from source to the destination is your base case. Okay, so you can just see that if n is equal to 1, you're moving it from the source to the destination. Okay, so else then you're saying you're calling 2 functions. Okay, so wherein the first argument is n minus 1, source, auxiliary, and destination, wherein you're changing the positions, wherein you're changing the names of sometimes even your destination may act like an auxiliary storage. Okay, um, so you're just changing the names over there. Okay, so you're making n minus 1 moves. Um, this is the C program for Towers of Hanoi. If you execute this, then the user has entered the number of disks to be 3. Okay, so if the number of disks is 3, then the maximum number of moves by which you will be finishing off this puzzle successfully is 7. Okay, 7 moves. You just need 7 moves. Okay, so all these are the moves that have been made. And so this is the output. Okay, so hope you liked the video, guys. Okay, please like, share, comment, and subscribe my channel for more videos coming up. On recursion, I'll also talk about the types of recursion in detail with execution shown. Thank you for listening to me.